Hey, yo. We're going to do some math today. Hope you're excited. We're going to rock out some area and circumference of circles. Okay. I've already put a couple videos up about approximation of pi and like the terminology or vocab that goes with circles. Now we're going to dive into a little bit of working with circles, finding the area and circumference. All right. What has one head, 1 foot, and 4 legs? That'd be a bed. Hmm. Boop, 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 boop. So today we're going to work on developing the formulas for circumference and area. When you understand how those work together, like how diameter and radius and circumference all work together, um, it makes it a lot easier for you to understand how I'm going to use those in a real world situation. So most of this video is going to be about developing the formulas and then practicing solving circumference and area. And once you have that information, you can use it to dive into some contextual situations involving circles. Okay, so a quick circumference review. Shown this in a couple videos. I think it's just a really good way to make sure we understand what circumference is. It's how long the outside edge of the circle is. It is the outside edge of the circle, and it tells us the distance around a circle. So this circle rolling out is turning into a flat line so that you can see how long this circumference actually is. And if we had a ruler, we could measure it with a ruler. It's hard to measure circles with a ruler. Okay, so let's talk about circumference formula. So this one's pretty simple if you just remember, like if you watch the approximation of pi and you kind of understand how that worked, just remember the relationship between the diameter and circumference. And so when we were working on approximation of pi, we talked about how there was a certain relationship or ratio between diameter and circumference. And what we found out was that the diameter, if we take the diameter and we multiply it about a little bit over 3 times bigger, it'll give us our circumference. Okay, so the circumference is the diameter multiplied by a little over 3. And that little over 3 eventually got us to the term that we wanted to say, which was pi, 3.14, blah, 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 right? So if we know the circumference is take the diameter and multiply it by pi, we'll be able to figure out how to solve these type of problems. So there's your formula. So this one's pretty easy. It is simply just understanding if we know the diameter, if we know the diameter a uh, of a circle, and we want to figure out what the circumference is, if we know the diameter, all we got to do is multiply it by 3.14, make it a little bit more than 3 times bigger. It's going to give us that circumference, okay? All right, so what's the other thing we know about circumference or radius and diameter? So we just figured out this is our formula. Circumference equals take diameter and multiply it by pi. But what if they only give us the radius? Okay, what's the relationship between radius and diameter? I'm going to keep pounding away on this just to make sure we get it. It is doubled. The diameter is twice the length of the radius. So if we know the radius, we can use the formula like this. Circumference equals 2 equals, or sorry, circumference equals 2 times pi times the radius. Okay, so we are doubling the radius basically so that we can get to the original idea of having a diameter. Okay, so here's our two formulas. And all you have to do is figure out which one of them to use when you see a scenario, okay? So for this one, we have a circle that has a diameter of 6 feet. How do I know it's a diameter? Because it's going all the way across. What is the circumference of the following circle? So which formula am I going to use? Well, it's giving us the diameter, so we are going to use the diameter formula. And then we plug in the numbers that we know. Circumference equals 6 times pi. Why do we put a 6 in there? Because that's the diameter of this circle. And when you multiply it, you get this answer. And that would be the circumference of the circle. And a lot of times when you're dealing with solving circumference or solving area, it's going to tell you to round to the nearest tenth or 100th. I'm just putting it in the actual answer with the dot, dot, dot to make sure you understand that that number goes on forever. Okay, so here's another circle. All right, let's see what we're going to do. 4.2 meters, and it's written on a line that goes all the way across, so it's talking about the diameter again. So let's plug in the diameter for our formula. Circumference equals 4.2, and it's going to be a little bit over 3 times bigger, which is pi, and we multiply it together, we get this answer. Okay, so this would be, circumference would be 13.194, blah, 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 and at the end you could say meters. And same thing over here, we could have said feet. Okay, and then over here, we got another circle, 4 feet's written in the middle. But this time we're going to use the radius formula because it's only giving us the radius. So we plug in that 4, where the radius goes, and then we on our calculator, we type in 2 times pi times 4, and we get this answer. And it would be that, and the answer would be in feet because the original scenario was in feet. Pretty simple, right? We just know that that circumference is a little bit more than 3 diameters, so we multiply it by pi. Now let's talk area. So you've done some area before, and here's just some examples of like what, when we look at area, what we're really trying to figure out is how many square units will cover the shape. And so with squares in particular, that's the first place you kind of learn about area. It's how many squares will fit inside of that square, or square units. So those might be inches. So you could say that with the area of that shape, let's say those were all inches, would be 9 square units, or 9 inches squared. All right. And we could do the same thing down here. And the other ones, we have some like half shapes. So you would combine your half shapes. But area is how many squares that don't overlap will fill a unit. Well, in circles, it's a little bit trickier. Okay, because we have a circle and we're trying to fit square items inside of it. So here we could put some squares in, but we also have this weird, all this other area on the outside. Okay, so we have to figure out how to, a formula that will make this make more sense for us. Like those curved edges really make it challenging. So let's make a formula for the area of a circle. All right, so let's say we got this circle, and this circle's already been broken into equal shapes. All right, they're called vectors. Not really that important for you to know that right now. But if we take those, and like I pulled out each one of them, I take this blue one out, I take this yellow one out, and I put all the blue ones in a straight line, I put in all of the yellow ones in a straight line upside down, you get something like this, right? Okay, so this is that shape broken into vectors that we formed into this type of shape by staggering them with a big side on each end, yellow, blue, yellow, blue, yellow, blue. That kind of looks like something I've seen before. And what it looks like is a parallelogram. And what's a parallelogram? It's simply a rectangle tilted, right? Parallelogram is a rectangle tilted. We already have an area for that one. The area for a rectangle is you just simply take the length and you multiply it by the width. And that'll tell us how many square units will fill that. So we can take that idea up to our shape, but we have to figure it's a little different because of those curved edges. So, but we can take that for a starting point to start our formula. So if we look, let me go back and we look at all these blue edges up here. So let me erase my screen real quick. If we look at all these blue edges up here, okay, and we say there's a blue one, there's a blue one, there's a blue one, there's a blue one, there's a blue one. They are all, at this end of them, they are all the edges of the circle, which is part of the circumference. And we have the same amount of blue as we do up top in the yellow, right? So if these were all blue and we went all the way around, we would have the circumference, wouldn't we? Yes, we would. But the blue represents half of the vectors, so it's half of the circumference. So for us, the length of this parallelogram, or our new shape, is half of the circumference. Okay? We just figured out what circumference means. It has 2 formulas. We're going to use the one with radius. So if this is the formula for circumference of a circle, it's 2 pi r, right? But we only want half of it. We can say the length is the same thing as 2 pi r cut in half, or divided by 2. I know this looks a little tricky. We're going to make it a lot easier here in a second, though. So what we're saying is the length, if we're trying to turn this into a formula, the length is equal to 2 pi r, which is the circumference, cut in half, because we only want one side of it, right? Because down here we're just dealing with this side. Okay? Then the width, if we look at the width, what we're dealing with is every one of these things started from the middle and went out. All right, started from the middle and went out, started from the middle and went out, started from the middle and went out. Well, those look like they went halfway across the circle. So the width is the radius. Okay, so the width is the same thing as r. And that's why we're using this formula here, is because the width is dealing with r. And it just makes it easier to combine terms when you have it in that manner. All right, so it's a lot written on the screen. Let's get rid of that and go back to here. So here's our shape. And we know that the length is the same thing as the circumference cut in half, which is that formula. And we know that the width is that. So let's turn it into a formula, okay? So area equals length times width, or that. Area equals length, which was that, and we multiply it by the which is that. Okay, so we're just going to combine that so that we can make it simpler. If I take pi times r and I double it, and then I cut it in half, I'm kind of just canceling those two out, right? Because 2 divided by 2 is 1. So I can cancel that. And I end up getting pi times r times r. R times r is a number multiplied by itself, which means it becomes an exponent, right? So that means this would be pi times r squared. So look what our formula does when we do that. Area equals pi times r squared. Now we have a formula. And we can use that formula to solve the area of any circle. All we have to find out is, what is the radius? Once we find the radius, we just plug it into our formula and solve, right? So now we have an area of a circle formula. So let's try a few. Remember, there's our formula that we just figured out. Area equals pi times radius squared. So here's a circle. It's got the radius given, right? 6 feet. So what is the area of the following circles? Well, we got area equals pi r squared. And this one tells us that the radius is 6. So we plug that in for the r. And when you type that into a calculator, we do the exponent first. 6 times 6 squared is equal to 36. And then we'd say 36 times pi equals, there it is. And our answer looks like that with feet squared. Because remember, we're figuring out how many squares will cover that. Feet to the second power. So we're saying how many feet squared. All right, here's another circle. And we've got 2.5 meters is our radius. Let's plug it in. Okay, and then you do the math by calculating that out, and you get the area of this one is 19.6349, blah, 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 goes on forever. Remember, it's probably going to tell you to round to the nearest inch or foot. I'm sorry, it's going to have you round to the nearest tenth or 100th. Okay, but this one was meters, so our final answer is in meters squared. Okay, let's do one more. Oh, this circle looks a little different. It's giving us the diameter. So if it gives us the diameter, and it's asking for radius, we just got to cut that in half because the diameter is the radius doubled, right? So what would the radius be there? It would be 5. And then once we plug that in, we simply solve our problem and we get this scenario. Okay, so the area of that circle would be 78.5398. Pretty good, huh? So now when you're looking at problems that have, there's a swimming pool involved and the swimming pool is this amount apart, how big is what's the distance around the swimming pool? Well, you could use your circumference understanding because circumference goes around a swimming pool. So you'd use your circumference formula. And if it was like maybe they're going to put a cover on a swimming pool, right? With a solar cover on top of it. Well, is the solar cover going around it or is it covering it? It's covering it. So your understanding of circumference, which is the same thing as perimeter, understanding the distance around something, and your understanding of area, which means how we cover something, will tell you which formula to use. Area means we're covering something. Circumference means we are surrounding something. All right, let's fill in the blanks. Understanding the relationships between parts of a circle will help you develop formulas and understand formulas. The formula for circumference is circumference equals diameter times pi, or circumference equals 2 times pi times radius, which is just simply saying which one we're given. If we're given the radius, let's use the radius formula. If we're given diameter, let's use the diameter formula. And the formula for area of a circle is pi times r squared. Not too shabby, huh? What did the blanket say to the bed? Don't worry, I got you covered. Giddy up.